Hi class, welcome to the challenge to prove some of the rules that we've been learning. This is another attempt at a one-take pre-written lesson. So let's get started. So in the first section, your challenges will all be about the sine rule. So we're going to mark in the triangle exactly as we have throughout this whole block. The angles A, B and C are there, and the side lengths A and B and C are also there. So what I've done is drawn two triangles. Now I've marked in the angles A and the side lengths A, and the same for C. And obviously both of these are the same. This H1, which I should write on the graph here. So I'll mark that in with a color. So I'll call this one here H1. I'm asking you, what can you say about these triangles that imply that A divided by sine of the angle A is equal to the side length C divided by the angle C? So you need to obviously use your sine, your trig, and manipulate a little bit, and you should be able to get the answer to that one, no problem. The second part of the sine rule is redrawing this. So I've written that number wrong there, by the way. So that should be H2. So if I go back to the picture, okay, I'm going to name this one here H2. And so I've drawn the triangles on that angle. So what can you say about these triangles that imply that B, the side length B, divided by the angle or sine of the angle B is equal to the side length C divided by sine of the angle C? So let's have a look at that again. Okay, so you should be able to tell me something about those, obviously related to this height here. Then part 3 is asking you, what does the answers in part 1 and part 2 imply about A divided by the sine of A equals B divided by the sine of B. And please, I hope you're not getting confused with A's and A's there. One's obviously capital and one is not, okay? Capital is for the angle. All right, so that's about the sine rule. So hopefully you can show that the three ratios are all equal to each other. And good luck with that. Section 2 is the cosine rule. Okay, and we're going to write out the triangle with the same ABC for angles and lowercase abc for the side lengths. But I'm going to break up B with this red line here, which I've given the measurement of X. And because the whole line at the bottom has to be B, then this blue bit has to be B, not X, or B minus X long, okay? So then when you put these triangles together, now, hopefully I don't have to go back up to that one. You should know that that's where they belong. Because we're focusing on the angle C and the side length C, okay? So if you look at these triangles, if you can use Pythagoras' theorem to express h squared in terms of C and bx and b minus x from the blue triangle. Okay, so I just want you to do that one step in this question. So think about that blue triangle and what is h, or what is h squared with respect to c and b minus x. Then in part 2, you're going to use Pythagoras' theorem to express h squared in terms of a and x from the red triangle. So I will have to scroll back up. So you can see the red triangle there. So what is h squared with respect to a and x? And then in part 3, use a trig function to express x in the term of a side length A and an angle C. Okay, so there's our angle C, and there's x, and there's A. So what is x with respect to C and A? Okay, great. So now you're going to use your answers for part 1, 2, and 3 to show that c squared is equal to a squared plus b squared minus 2ab cos of c. All right, and then part 5, we're going to look at this triangle where C is a right angle. And I want you to just use the formula for the cosine rule and tell me, is it consistent with Pythagoras' theorem? And if so, why? If not, why? All right, another part to that one. Seeing we've used Pythagoras' theorem to prove the cosine rule, can we use the answer to 5 to prove Pythagoras' theorem? So maybe that's giving away what the answer to 5 is, but this is more about a logical approach. So if you've used something to prove something else, can we then use the proof to go backwards and prove the other thing? So some of you might want to look up what a circular argument is. All right, section 3, areas of triangles. So how does the trigonometry rule for area of a triangle prove the sine rule? Okay, so this is back to section 1, and it might not be much of a stretch from that for you guys, but still interested to see your answers. And step 2, I think this is the last one. No, it's not. We've got a parallelogram here. A and B are the side lengths. It has this height h. Okay, I'll just highlight that. And I'm asking you to draw a diagonal in the parallelogram and explain how the area for a triangle using trig is consistent with the rule for an area of a parallelogram. Okay, so you need to think about what triangles exist, and maybe that h has something to do with it. We'll see. Okay, but can you use the trig rules to show why the area for the parallelogram has to be b times h? And the other part is that you see that I've drawn this j here. So j is sort of like the height going from A to A. So I want you to express the area of the parallelogram in terms of A and J. So for A, my tips for you is for parts 2 and 3 here, you might want to slide J and H along, redraw this parallelogram with H and J in the correct place. All right, and I think that's the end of that. Yes, that's the end of that. So good luck with the challenges. We've had a really long unit here for trigonometry and geometry. So I look forward to seeing you in our probability unit next. Bye.